Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching a special series, Hero to Superhero. Why? Because this series is designed for pretty advanced level, especially PhD folks or even for the professionals who are very good at machine learning and artificial intelligence and deep learning. So basically guys, this is all about coding artificial neural network. So we are building a neural network from scratch. So in the previous lesson, you did see about the basic, initiating the neural network. This is the code which I talked about, right? So it's pretty interesting. I hope you guys understood line by line, which I explained in previous 2-3 videos. So go ahead and pick up this code. So in this particular lesson, we are going to do the neuron activation. So this is the code for calculating the neuron activation for a given input and the weight. So we are actually, it's pretty simple. I mean, if you look at it carefully. So basically the first step is to, calculate the activation of one neuron given in a particular input, right? And then the input could be a row from our training data sets, which is the Weed data sets, which is in my GitHub repository. I hope you guys have downloaded that. And as in this particular case of a hidden layer, we are going to use that particular training data sets, right? Which is going to walk through from the input layer to the hidden layer and to the output layer. That's going to be the magic. That's going to be the Maya, right? So it may also be the output from each neuron in the hidden layer in case of the output layer, if it works, right? Now the neuron activation is basically calculated as the weighted sum of inputs, pretty much like a linear regression. So those of you folks who are from machine learning background, you will definitely understand what is a linear regression. I don't have to explain that, right? Anyway, so basically the calculation, the sum, the formula for that is activation is equal to sum and weights underscore I multiplied by input underscore I, and plus we are going to calculate that with bias, right? So where weight is a network weight, what is the amount of calculation you need to add the weight for calculating the accuracy, and input as I, and I is the index of a weight, or an input, and bias is basically a special weight that has no input at all to multiply with, or you can also think of input as always being 1.0. That's the standard thumb rule, I would say. So this code is basically the implementation of this particular function named activate open parenthesis and close parenthesis. You can see it on the IDE. That is the function, which is a user defined function we are creating in Python. So that's going to activate it. You can see that the function assumes that the bias is the last weight in the list of weights, the total list. I hope you guys understand the tuples and list and stuff like that. I'm not going to talk about basics of Python, so guys, you need to bear with me. So this basically helps here and later to make the code easier to read. Now, basically if you look at it, once the neuron is activated, we need to basically transfer the activation to see what the neuron output actually is. That's the end of the course. We will run the entire neural network with the data and see the output. So guys, go ahead and pick up this code. I'm going to leave this particular section of the code. At the end of this lesson, end of this particular course, Hero to Superhero, I'm going to combine this entire stuff into one single file. So you need to combine the initialized network from here by importing random, the seed data, and then of course we are creating our own user defined function that is to initialize the network, and rest of the things you understand that. And then in this particular lesson, you know how to activate the neurons. In the next lesson, I am going to talk about the next steps, which is going to be very interesting. So go ahead and pick up this code, combine this together, and wait for my next lesson. Until then, goodbye.